a lot of like administration, operation, and infrastructure. So currently, I'm a solution engineer in StreamNative. Right. So this is my background: EMC, Pivotal, and VMware. So let's get started. Our core product is actually called StreamNative Platform. So our products built on Kubernetes. So no matter it's private cloud, hosted cloud, managed cloud, it's all on Kubernetes. Okay, so there's no bare metal, there's no virtual machine, right? All the Pulsar is built on Kubernetes. Okay, so it's important to understand why do we choose Kubernetes, right? And why this is add-on, what customer we are looking at. Okay, so I'm going to talk about the Pulsar cluster using operator, right? How to handle failures and discussion and demo. I have assumption about the level of understanding of Kubernetes. Okay, so I hope that in this go, after this training, you can install a Pulsar cluster using our product and start to work around, work on it for a little bit about demo. For the field team, you can understand how to do validation, right? For example, support team, you have ticket coming in, how do you build up a cluster, then start to validate that, well, if this is a bug or is a configuration issue. Okay, so two things. One is you need to understand what's custom resource, right? So how do you work with custom resource? Pulsar operator, right? So how do you install operator? And how do you use platform, okay? And have some kind of troubleshooting tool we can use. So you will see me doing demo using two tools, Kubeclt and Lens. What's Lens? I have here, this is the Lens. This is the GKE cluster I create for the demo, right? So you can see that this is a cluster, has 3 nodes, have different resource. We're gonna look at this custom resource, right? So here, once we install something, you will see additional custom resource coming up. The other tools, Kubeclt, right? So this is command line tools. This is GUI interface. They work like IDE. You can use both tools to diagnose what happened. Okay, so go back to the slides. The reason why Kubernetes from a I think from Hadoop time, I think that's 10 years ago, right? So that's the boom of the distributed system, right? So before that, everything is a single server. If you have Oracle database in 10 years ago, it's a bare metal server. It's one server like your desktop, right? You install Windows and you install Oracle. You install application server like WebLogic, everything in one box, right? So in that time, what happened? You have more traffic. How do? You're asking for more powerful CPU, more powerful server, right? More memory, more disk, right? Bigger switch to handle the workload here. You can scale up, right? You cannot break down. Typical server like Oracle database, Teradata, you're getting bigger. So then we go to like 2-tier, 3-tier server, right? So it's like, okay, let me break up application and DB to different server, but they are different server. And how do we connect? Using network, right? So yes, there's a network here. And this is work like 1 or 2 years, right? So it's like, oh yeah, I break up different server. I can pick smaller hardware for app, but bigger DB, a bigger hardware for my Oracle database, right? It worked maybe 2 or 3 years, right? And you start to think that, oh, my DB, because my traffic is like have a couple of seasonal traffic, right? So holiday season, shopping season like Walmart, right? I need powerful server. Sometimes I get website down because too many customers coming in, right? So, but when the holiday season is over, what happened? Although it's 1%, but still burning my electric bill, right? I still pay in Oracle service, professional service. They need to come in to every day, every week to check my server, right? I still pay in the bill. So next stage, virtual machine is like, okay, let's build virtual machine on bare metal that add a new component called hypervisor, right? So on the hypervisor, I can build VM. Inside the VM is just like exactly like this, bare metal server. So you can contain multiple VM for multiple server, but it squeezes the resource. It keeps your CPU, memory, electric bill 100%, right? But if you don't need it, you just kill it, right? So it raises your utilization, right? So you can scale out. The scale out is like adding more virtual machine here for different usage, right? So this worked well for VMware, right? So for, I think, 5 or 6 years, right? And then container coming in, right? So it's like, hey, hypervisor is expensive. Normally, it's not open source. You have to pay VMware a lot of money to maintain this, right? So at that time, open source start to jump in, right? A lot of people using Linux, free open source tools. They build open source and make everything container, right? So they skip the hypervisor. They build Linux to couple of replicate the function of hypervisor, so everyone can run container. And you see that there's no guest OS, there's no Linux, no Windows, and build your application on guest OS, right? So it's more straightforward, and you can add more container, right? But it's still one server. This is a Docker time, right? So I think it's 5 years ago. Docker is popular, right? So after this, it's like, okay, you still need to grow up bare metal server, right? So you still bound it into one server. So Kubernetes coming in, Google has a new solution, right? So basically, they make all the different bare metal talk to each other. You can have multiple bare metal server to make container talk to each other, right? So it breaks bare metal boundary using the network to connect together. Okay, I think it's here, right? Container network time. Okay, so you see that bare metal server, they can talk to each other through this container network. Okay, so this is how we come in, right? So what the Kubernetes bring in is about this, right? So I discussed each stage, what happened, velocity, scalability, right? Only scale up and start to break down, become a 2-tier, 3-tier server, right? Then you go to virtual machine, right? So in virtual machine, you can add multiple server, right? So, and you go to the container, right? Everything is loosely coupled. You kill this container, you're not gonna break DB container, right? So it's more scalable. Right? Container network is like, then people start to think about how to connect together, right? So it's more cost effective. Remember, this is a logical view, conceptual view, right? So what happened physically, everything look like this inside data center. No matter you are private data center or Google data center, public data center, physically it's all box with cable, we call it drop, right? So if you have a chance to visit a couple of data center, it's pretty much it. Power going from the bottom under the floor, network going from the up called drop. So, and every day, no matter private cloud or something, or it's Google Cloud, people work around replacing hardware like disk, memory, network drop, right, or even power unit, right? So it's varying every day. It happens every day. Physically, no matter you are using Kubernetes cloud, this happens every day, right? The impact, the differentiator is, will this replacement impact your workload, right? In cloud, you don't see it. In Kubernetes, you don't see it. Because it can scale out, it can move around the container to different metal server bus, right? So you don't feel a thing. This is called cloud. You're not gonna impact by this physical hardware failure replacement. This is why we do Kubernetes. Okay, so what's Kubernetes? It's portable, extendable open source platform, right? So it's open source, everyone use it. And the good thing is, let's know, like the concept is like, is serve containerized workload and service, okay? So it just facilitates the clarity configuration and automation. What does it mean? When back to the data center time, right? So if you work for IT, you understand that if you want to have a server, you submit ServiceNow ticket, say that, hey, I need 5 CPU. Okay, and how many memory, how big the disk will be, right? And maybe 2 weeks later, it's like the IT team tell you that, oh, it's gonna cost you $2,000 a month. Okay, give me your invoice. And they start to deploy this, and you get a lot of team coming in, system engineer, network engineer, security engineer, work on your virtual machine, and they give you the ID and password to log into the server. Then you start to install your software, right? But this is called declarative. The ServiceNow ticket is declarative, right? All the underlying, you don't see the network engineer working on the bus. But go back to that data center view. It physically happens in data center, right? It need to arrange power. It need to arrange cooling. They need to arrange network drop distance, right? Network, it cannot last like 100 meters, right? If over 100 meters, your signal drop and your network will drop, right? So all the things happen, human engineer, field engineer there, right? So it hit very hard on COVID-19. Why? Due to policy, right? You need to get physical person enter the data center to do something for you. And it slow down, right? It's getting slower and slower to provision this. But in Kubernetes, everything is automated. You just write a declaration and it happens. So why Kubernetes? Everything is automated, okay? So service, network. Remember, in data center, you have network, you have computing, you have storage, right? It happened, if you submit ServiceNow ticket, it takes 2 or 4 weeks. In some security environment, even take 6 months to get you to the console, give you a user ID to log in, right? But in Kubernetes, it happened like 2 seconds. Everything happened like 2 seconds, right? So it's a self-healing. It's like, it doesn't even drop, right? If your part fail, it try to restart itself, right? If the hardware node fail, it move your workload to the other bare metal server, right? So all this config is all managed. I'll go through the demo, but basically component is you have control plane, right? You have data plane. Control plane, you can think it a lot of the manager, controller manager. Basically, it tell what need to be happen, right? So how do you schedule part into the data plane? Data plane is the worker. Okay, so if we go to LANs, we have worker here. I create 3 worker. equal nodes. Okay, so I have three virtual machine running here. Okay, so make it simple, right? So what you want to do, you just need to understand Kube API, right? So you interact with the Kubernetes through this Kubeclt. Okay, so what Kubeclt help you to do is authentication, authorization, administration control. So give you an example. There's different command. Oh, let's no, can I? Oh, I'm little lost it. You see that? Kubectl authentication, can I get namespace? Right? You say yes. So basically, when you run Kubectl, this is important. It's like, can you do what? It will tell you if you can do it or not. I think this is the link. How do you install your own environment, Rancher desktop, Mac, or Docker desktop? Multiple choice, right? Docker desktop, Rancher desktop, they all have Linux environment, Linux version, Mac, and Windows version. Also, one thing is good is lens, right? So this is how I use. This is look like Kubernetes IDE, right? You can see everything here. Workload, right? So this is a workload, like your compute unit. There's a part, deployment, stable set, right? You have config, a secret, right? So config map, network. You see, this kind of like weird service. Why do I say service is a network concept, right? It's actually network concept. It hide all the complicated network concept into one term called service. And you have storage, right? So you can create storage, right? So all you need to do is write a YAML file and you will get what you need. And this is custom resource. We'll come back for this when we do operator. Okay, this is useful resource, Kubectl cheat sheet. So there's some helper tools that you can read on that, right? So cheat sheet, how to do, how to get information, how do you create resource, create different component storage using the Kubectl command. Here's code concept part, right? Part is unit of the compute resource inside Kubernetes, right? So what you can do is part, right? You can create part. You see that there's a lot of part already running here. Matrix, right? So it tells you, this is really cool tools. It tells you how many CPU, how many resource network file system running on this environment. It tells you like where this node, where's this part running on which node, what's the condition, right? Running status, what's the image, what's the disk values, right? So what's the credential you can access, like token, what's TLS, is all built in. So you really don't need to worry about security, network, or the detail in different data center. It's abstract, everything concept like those components here. So you see that workload, service network, config map. Config map is like where's your Pulsar config, right? So you want to do some multiple topic partition, those things. You can manage by config map. Secret, as a secret, is the password, for example. Persistent volume is basically the storage. What does it mean? For example, if I want to create a container, right? I need to write a YAML file like this, right? So this is the kind of format you need to have. It's called part. What part? This is the name of the part. Containers, you can have multiple. If you don't understand YAML syntax, if you read the YAML file, you understand this is kind of like list, right? So inside containers, is a parallel, right? So you can have multiple containers inside a pod, then they work together. And you have ingest. This is an image. Image basically is a work, like Pulsar broker is image. We have different version, right? So you can upgrade it. We'll show you how to upgrade it. And what's the pole? Because the container is not an island, right? So you need to interact with the container. So it's pole to pole. So the pole basically like AT pole, HTTP pole. You interact with this container through the HTTP AT poles. So basically, this is like service account. Service now TK is like, hey, I need a server, a running ingest version, and I need to open the pole here, and it's done, right? So deployment is same, right? So deployment is more like, well, part is only ingest, right? So if you kill it, there's no management, right? So it can survive, but it's kind of like temporary here. Deployment, basically, it controls how many copies. Okay, so basically, this is a pod. You can tell the pods like, oh, I need an ingest, but I need to keep 3 copies of the ingest, right? And what do you mean? If my node die, example, no, right? So if my pod in this node die, what happened? I have 2 more copies here, right? It's still serving the same process. So this way, if I have 3 nodes, 3 bare metal server, right? I'm not gonna worry about one node is down because I have the other 2 copies serving the same purpose, right? That's called deployment. Okay, and you can roll back, right? So if you change a version, it's a buggy. For example, you try the 1.14.2 and someone tell you that, oh, it's buggy, I cannot visit AT pole. And support engineer come in and say, oh, there's a bug, let's upgrade it. You just change the version, it's automated upgraded. Okay. Also, you can do what? You can increase the CPU, increase the memory, you can decrease all the resources, right? And you start to replace it one by one. We will show you this in demo. It's amazing. You don't, in bare metal world, it's like basically think about it. In the first step, what if your hardware fail? You send a field engineer to a data center, right? So you tell ServiceNow, you tell your customer, oh, I need a maintain window 4 hours, right? So you shut down the server. Your service basically is down for 4 hours. So you do this maintenance. But in Kubernetes, nothing. It's just like it's just rolling upgrade, rolling maintenance. Your customer has no any impact here. Okay, so this is deployment. You see that there's no storage, right? So it's like I'm serving, this is called stateless, right? It doesn't matter, you have 3 copies. It doesn't matter which container serving my request, right? They are all the same. But for data, like Hadoop, right, or for Cassandra or Pulsar, each broker has its own ID. ZooKeeper has its own ID, right? So it's important to understand the order of the each service part, right? So it need a unique ID. This is where we deploy Pulsar, right? You have 3 Pulsar broker, each one has its unique ID, right? And each one has its own storage, right? You can say that, hey, this broker, I need 2 gig storage, 1 gig storage, right? So, and all this stateful set deployment is built on, you see, pod here. So basically, they all built on pod, and stateful set is extra with storage and unique ID. So daemon set is kind of like special, right? So daemon set, normally it work with node. How many node? In my example, I have 3 nodes, right? So then I will have 3 daemon set. You see that this is all daemon set, matrix agent, right? So this matrix agent work with node. You see that's 3 part. 3 node, then you will have 3 part. Okay. So job and cron job, they are temporary, right? So if come in, do something, and get out, it's not long last container, right? So what is, for example, cron job, do something like print, do some action, then once it's finished, it will be disappear, right? Cron job, you can specify the time, like cron, right? So run this job every day, 12 o'clock, something like that, right? In each minute, what's the hour, what's the day of the month, day of the week. You can schedule a job to run specific action, right? And it will run it like a schedule. So job and cron job is very useful. Service is basically network concept, right? So it's how to integrate to guide you. Think about it, it's kind of like load balancer, right? So for example, you have three containers, you have 3 parts, right? So how do you access the 3 parts? You go through the service, right? It will do kind of like round robin to go through different parts to access the resource, right? So config map, something like this, game property, you are a color, right? So this is kind of like, remember everything here, the concept is YAML file, right? So you can specify different game.property, right? So give this your application property, you can use config map, right? So then this is the definition of config map. This is how you add the config to the part, right? Using the volumes command to associate this property to your container. Secret, normally people using a username password, right? So this is not really secret because it's just a hash version. So you can basically translate back. But well, this is the design. Is like if you want to keep something not clear, secret is the way to go. Okay, this is a config, right? So here we go back to the physical volume, which is the disk, the storage, right? So this is definition of storage. It's storage class, that's the persistent volumes, that's persistent volume claim. This probably too much for because storage is really your mileage may vary because different provider, they have different behavior, they have different performance and requirements. EKS, GKS, AKS, or Tanzu, right? Rancher, they have provide different storage, right? So this is a big topic, but but think about it, it's just a storage, right? So you don't need to worry about too much here. This is called role-based access control. So this is another big topic about authentication, authorization, who can do what, right? So role-based access control is very useful. I think Pulsar is also using, adopting this role-based, right? So access control. So basically you have subject, right? So what's the subject? It might be a group of people like solution engineer, R&D, or SRE, right? And you might be a user, right? So your user ID, right? Or service account. What's a service account? Service account is like there's no connection to any individual in your organization. Normally it's agent, something like it's a service that, for example, Pulsar runner, right? So logical account, you need to create something that to create Kubernetes access the service, but it's not binding to any other individual, right? So it's kind of like virtual. So this is your subject, right? And you define operation, what kind of action you can do, like create, list, watch, delete, get, right? So you can also have resource, config map, path, deployment, no, right? All the resources we just mentioned, deployment, stateful set is all resource, right? So basically, this RBAC control is basically define who can do what to the resource, right? So it goes through this YAML file to do that. For example, service account, right? So you define name, right, and give it a secret password, something like that, right? And you can define a role. The role is like basically define what resource you can do. For example, this role can get path, watch path, and list path, right? So then you bind it. That's two roles. One is called role. The other is called cluster role. Cluster role is like it's global. It can look at all the cluster-wise resource, right? And single role is namespace. You see that there's a namespace here, right? But in cluster role, it's like it cross multiple namespace to access the resource. This is important. You define role, right? You define user or service account, right? And role binding is basically bind together. What's the subject? What's the role, right? It make that link together, which means this define who can do what here. So this is the thing that I do, right? Kubeclt also can I create deployment in namespace, right? So basically, this is kind of like good troubleshooting you should have, especially support engineer here. Basically, once you define, if you do run this command and say no, that means you have to go back to check this role binding. When you log into Kubernetes, you can use this to check if you can do what? Custom resource. Basically, those resource, service path, no, deployment, this is called resource. Those are built-in resource. Okay, so if you go to the lens, you will see that workload path. This is called all built-in resource. You can create path, you can create stateful set. The question is, hey, Pulsar StreamNative product is built on 3 projects: BookKeeper, Broker, and ZooKeeper, right? So each one is stateful set. It's like, how do I need to maintain 3 stateful set here, right? So it's tedious, right? So if you want to tune it, it may not work together because there's integration part that need to work together, right? So stateful set, and when you create a cluster, Bookie cluster, you need to go network connecting to ZooKeeper, right? For example, remember ZooKeeper is a service, right? So you have to build service. So your BookKeeper can talk to ZooKeeper, right? So that's kind of tedious, right? So you have to deploy the Pulsar. If you do this default resource, there are multiple resources involved, right? So Kubernetes provide API extension. It's called custom resource, right? So the idea of StreamNative is like, hey, I'm gonna wrap up all my Pulsar cluster as a single resource, right? So they can just use the same concept of the stateful set, but I'm going to read everything together, ZooKeeper, BookKeeper, broker, into one single YAML file, right? That's the reason we have custom resource. To maintain custom resource, we need to build operator. What's operator? Operator basically like is mimic human operator, SRE, right? Who implement the day one, day two activity. For example, deployment, upgrade, right? And monitoring, right? Those features normally handled by field engineer in data center or the DBA, right? Database administrator, network administrator, or security engineer, right? So they update those information, update the software for you. But in Kubernetes, operators are software artifact, right? They are code. So our StreamNative value is basically provide software operator to do this life cycle, upgrade, deep insight, multi-tenant, a normal detection, right? So this is our value. This is a differentiator of our StreamNative SM platform vs the Apache Pulsar open source version. Okay, so two things you need to consider. Custom resource and definition, right? And custom controller. Okay, controller basically is the operator. We'll demo that here. So, okay, I'm gonna jump to my, go back to my lab. I'm gonna follow the lab here. So, lab one, I'm gonna demo this, right? Lab one here, you see that this is the step to run the, so normally you just copy paste here. Okay, so helm repo, this is the tool we use. Helm repo, we add a StreamNative here, right? So if you do helm search repo, helm search, you see helm search repo, you will see that we offer multiple module here. We're gonna install this, right? So here, if you see the, let me create a namespace here. Okay, so I'm gonna create a system namespace. So next step is basically install the operator, right? So create namespace here, helm install. So basically it's there, I want to install Pulsar operator in SN system with this stream, right? So Pulsar operator here. Go back here, copy paste. Okay, so let's see namespace. You see that SN system coming up, nothing here. Okay. Install successful. You see that in namespace, SN system, you see 3 parts, right? So you're gonna take some time. So you see that one is running. You see 3 deployment. Everyone is deployment. So if you go to part, you see that we have operator, BookKeeper operator, Pulsar operator, and ZooKeeper operator. Okay, so they are running fine now. So if you click here, you will see, you can check the, you can see the, you can log into the container, like it's a virtual machine. You can see the log here. You will see a log here. You see Bookie, it's controller, it's scanning all this config map, right? And all these things. So basically what I tell you is like, I'm standing by here, give me operation, give me some instruction, and I will fulfill your instruction, right? So the instruction is called custom resource. Okay, so we have, so from here, you can see that we have three, this is a command line tools, right? Get path, and you will see three paths here, right? So what happened here? So go back to the CR. Oh, you see that? This is new, right? ZooKeeper StreamNative.io. When you install the operator, actually it creates custom resource here. Okay, the ZooKeeper cluster. You can have Pulsar cluster. You see that there's a resource here, new resource. These are a couple of instructions you can define, right? So this is a lab one, right? So you can, from command line, you can do this, could be API resource, and you will see those definition like lens here. Okay, this is called CR. There's a lot of CR in this button. It looks like nothing happened, right? So what's the value here? It's like you have operator, human operator standby to accept your ServiceNow ticket. So let's create a ServiceNow ticket. So lab 2, deploy CR. Okay, so what's the CR? This is the CR. Okay, so basically, this is the CR. What it describes, okay, in order to work with ZooKeeper, build a Pulsar cluster, I need a ZooKeeper cluster. Here is my order, right? I want to use StreamNative image Pulsar 29217. How many replicate? 1. You can make it 3, and you can define the resource. What's the CPU memory? What's the storage size, right? And you see that you can define multiple storage here. So basically, it's a very simple CR. Let me do it this way. This is ZK CR. This is, you see that this is I created one, right? So what you need to do is just Kubeclt apply. Oh, let's try multi-tenancy here. According to the lab, right, we need to create namespace, create a Pulsar namespace. Okay, so go here, go Pulsar, right? So then what you need to do is could be apply dash n PULSAR Pulsar. You see that after you create a Pulsar namespace here. Okay, let's swap to it. No part here, right? But here's as apply Pulsar -f zk server.yaml. Okay, so basically this is like, okay, I need a ZooKeeper cluster. You see that it jump up my zk 012. I have 3 nodes here. It's all stateful set. You see that it start to deploy it, right? So it's so simple. You just define this and say apply, and then it's running. Okay, you see pulse. It opened the pulse. It do the network engineer thing for you, right? It set up all the environment. This is the Pulsar config, right? This is all Pulsar config. Normally, you have to manually write this, maintain this, right? So you see you have data here, right? And you even have a lot of sensor, readiness, liveness, and different topic data config map here, right? So it's pending for some reason, but you see that it's running. One is running, the other is running, the other is, everything is running now, right? next step is right now I have a ZooKeeper cluster, right? I ask for this one command, and you have a auto config ZooKeeper. They work together, right? So next step, do the same, right? So after ZooKeeper is up, I can bring up BookKeeper, right? So k apply -n Pulsar -fbk cluster. Okay, you see that this is a job, right? So what the job is doing is running. So in the job, you can understand what this job is doing. Oh, because it's finished, you see that job finish and disappear, right? And after it disappear, you see 3 bookie up, right? It's pending, and it start to bring up BookKeeper up. Everything is running, right? Next step. Broker. I can bring up the broker. You see the same. This is a job. It's pending, right? When you finish the job, you see the argument. It's running this command. Okay, so it's running this command. When this command finish, the job will, it's still pending, it's not running. I see that bookie is up and you have auto recovery here, right? So let's wait for this job to finish. This is like, if you're doing virtual machine, bare metal, you have to run this. You have to configure those yourself. And think about, you have 100 nodes. You want to scale out. You have to measure everything here, configuration, all makes sense. Okay, you see that I bring up 3 brokers, right? The job is disappear. And they start running well. Okay, so basically this is what happened, right? So you can log into the broker. You can log it to, it's running now. So if I log into the broker, I can run Pulsar command. Right? We have tenant, we have topic. You can start to do something like bin Pulsar client. Produce something, right? So it start to send out message here. Okay, so you see that I have 1 broker up and it's bringing up everything, right? Okay, so what else? You see that 3 commands to bring up your Pulsar cluster, right? So this is what you see that everyone is on stateful set. If you go to the stateful sets, right? This is stateful set. You have broker, you have auto recovery, you have ZooKeeper, right? And how many paths here, right? So this is how to use the operator, right? But hey, it's good, it's easy, right? And it's just deployment, right? So what else we can do? You can check this. Okay, so let's go to lab 3. Reconfig CR, right? So it's like, hey, I want to change something. For example, I want to upgrade. Okay, so remember this in current version, my ZK is 2937, right? If I want to downgrade, can I downgrade? Yes. What you need to do is go to the CR You see, we have CR called ZooKeeper, right? This is my ZooKeeper, right? Edit it. This is a YAML file. Let me extend it. State spec here, right? 237. If I change it to 292.17, what happened? Save and close. Let's go back to the part and see what happened. See this? It's not ready. Okay, so we see that it start to load in upgrade. Pending one. What happened? ZK0. Oh, here. You see? It just swap it automatically to 292.17. But you see that this one, oh, this one finished. It rolled in upgrade back to 292.17. Okay, so basically, this is how you downgrade your ZooKeeper. Of course, you can upgrade, right? So you can do so ZooKeeper, we see that 292.17 is ready, right? So if you want to come back, you can roll back, right? So here, I'm not going to show it here. Let me cancel it. So it's easy. You can do a lot of things here. ZooKeeper, Pulsar broker, right? You can do the same. You see that this design image 292.17, right? So you can change it. Okay, so basically this is how we reconfigure CR. Also, you can change the memory too, right? So let's try it again. Let's change the memory, scale up, right? Or you can increase the number of ZooKeeper. Let's use ZooKeeper. Replica, I want 5 replica. For example, I want 5 ZooKeeper. Let's do 5. Save. Let's go back to see the part. ZooKeeper is up. Auto scaling. You don't need to worry about how my new part work with the old part here, 012. It's auto config. Right? So all you need to do is change the CR here. You change what you want to do. Everything is automated, right? You can. Okay, you see that? Not ready is equals 3, but you see ZK4 is ready. You can, let's try it again. You can specify storage here. You can resource. I'm looking for resource. Yeah, anyway, you can do many things here. Initial limit, image pool path, resource here, right? If you do A, save, right? So it do rolling upgrade again. It do it one by one. Okay, so it swap it and make sure it's still the other 4 still working. Then once the ZK1 is ready, and it swap it. So now resource change. Anyway, this is how the custom resource jump in. This is our operator working, right? So this is lab 3. There are many things we can do. For example, so this is a CR, right? So the drawback is you still need to define 3CR, right? So, for example, you need to, there's an order here, ZooKeeper, right? And you have to set up ZooKeeper first. You define ZooKeeper, right? So, and you define BookKeeper, and there's a dependency here. You see, that's a reason you need to define ZooKeeper first, because there's a dependency. BookKeeper relies on ZooKeeper server. Okay, this is the server name. Okay, so, and broker also has ZooKeeper server dependency, right? So somehow you this is not convenient. In resource operator, you can see resource operator here. In Pulsar, you see that you can even control a connection. You can create, control the namespace. You can control permission, right? You can control tenant and topic. Okay, so basically this is called resource operator. Tenant, topic, permission, namespace, connection, right? So you, so this is just a couple of screenshot. You can validate in your lab, right? So this is the code. You can run it, global SE practice, tree, Pulsar apps, right? You can get it from here. So this is an example, right? So how many replicate, what's the CPU memory? Okay, how do you run it? BookKeeper and Pulsar broker, right? I highlighted that there's a bit dependency. You have to make sure you have the list right. The same on Pulsar proxy. You see, proxy need to have another dependency here, broker. Okay, so can run through it. This is a couple of the tests I tried, right? So you can upgrade it, change the image version, change the replication, right, from different version, and try to update it, and you see it during rolling upgrade, right? So if you want to test it, basically create traffic, right, and have some kind of simulation workload that come in that, hey, I produce some message to topic. At the same time, what happened if I upgrade my ZooKeeper? What happened, right? Nothing happened. It just goes to upgrade. Your producer still producing data. Feel like there's nothing changed. This is a very beautiful thing. This is very hard to implement in virtual machine layer, in bare metal server layer, right? Because it's very hard to do that because there are so many different vendors on the storage, network, and server. So module 3 is our StreamNative platform. It's our private cloud offering, right? So what is StreamNative Hemtra, right? What's the difference of what we demo, operator and StreamNative, right? So in this module, you got to learn about Hemtra, right? So so many Hemtra. Apache Pulsar has Hemtra. Operator is a Hemtra. SM platform is Hemtra, right? So what's the value here? We're gonna talk about this. So Pulsar is not an island, right? So there are many things you need to integrate. For example, monitoring. What if a customer wants Datadog? What if a customer wants Splunk to monitor your Pulsar? What if they want to do single sign-on? They want to do Flink with Pulsar, right? They want to do a lot of cert manager. They want to integrate with Vault, security, right? So public domain, how do you do that, right? This is how StreamNative platform jump in. It helps you integrate everything for you, right? So this is very low cost. This is like Pulsar operation is like, okay, give me Pulsar, right? And give me the cluster here, and I can produce. That's it, right? It's very still very technical deep, I would say that, because you need to understand Pulsar, you need to understand the architecture, right? And when you say, okay, this is still an island here, because my user doesn't know how to interact with this part here. Right there, I have that running, everything is running, right? I have auto recovery, but how do I monitor it? How do I know the traffic? How do I know that there's a bad user create a crazy topic, crash my server, and I start to see broker to keep restarted? What happened? How do you monitor it? How do you troubleshoot it? Right? There's a lot of question. Integrate. It's like, hey, I want to, because my client traffic is coming from internet. I need to measure encryption is end-to-end, right? It's like, how do I do it? Operator not helping you here. Other operator in this namespace not gonna help you because they only watch the CR, they understand. The custom resource, they understand, right? So this is how SM platform jump in. SM platform is a composer, okay? So it make everything. So here in operator, you have 3 YAML files or 5 YAML files, right? SM platform only have 1 YAML file. Okay, you just describe what you need in 1 YAML file, and you make it happen. Okay, so basically what platform doing is like you define 1 file, right? Then they're using helm install the same command. It will create a lot of custom resource, not just this is operator, remember? There's a certificate for TLS. There's a monitoring tools. There's a secret. There's other config map, right? And you talk to API, then you get all the things happen. If you need Prometheus, it auto-generate. If you need Vault, it auto-generate. You want to set up TLS, you want to set up Istio, service mesh, you will do that. Okay, so remember, StreamNative platform is built on operator. So basically, what we do in lab 1 to 3 just kind of like experience what Pulsar operator is doing, right? So that we have SM platform is built on this. There's some other prerequisites here. So manager. But right now we cover take it off is optional, Vault is optional. So we don't need to do a lot of things here. So remember, you only need 1 value files. Okay, so let's go through this. So in the value files, this high level, what's inside the values file? Inside the values file, you define components, right? So components like, do you want Pulsar? Do you want ZooKeeper? Do you want BookKeeper? Do you want Grafana? Do you want TLS? Do you want KLP? This is all components, right? And there's a monitoring stack. That's an image. You can control like, okay, what version of the components you want to use? Do you want to turn on TLS? Do you want to do OpenShift? If you try to deploy OpenShift, we also support that, right? So inside this overall, you have those major components, right? First, you define what component and what's the step. Then in the values, each component has its own session to customize, right? So those like sub-component. So it's 2 parts. Overall, it control what type of component to deploy it. then you can customize each component. Okay, so this is overall. So once you define this values.yaml, you just run this to get those SM platform running. Let's switch to demo. Let me get this out. Terminal. Okay, so I have a subfolder called SM platform. You can find it in the GitHub. This YAML file, I have many different YAML file. For example, you want to turn on TLS. This is example, right? So if you want to do 210, change the image version. You want to do monitor. You don't want to do proxy. You want to do Istio, right? You want to do different PVC. You can do that. Okay, so let's see. How do I go through this? Okay, this is what I mentioned. Let's bear with me here, right? So basically, you tell what you want, right? So basically, this is a component. I don't want vote. I don't want function, right? I don't want Pulsar. I don't want proxy. You just set it here, right? Basically, the reason I put basic is match to what we did in lab 3, right? I want to basic operator to deploy very basic Pulsar cluster. So I turn off everything, right? There's no authentication. There's no authorization. This example is like, hey, I want ZooKeeper. I want resource. I want JVM configuration, right? So this is a new parameter. This is like, okay, what BookKeeper looks like. Everything writing inside this value file. Okay, so how do we deploy it? Let's create create some get NS. You see that I put this in one cluster here, right? So I can do create NS platform. Let's call it show for SMP. SMP, nothing here, right? In Pulsar, we have component like this, right? So in SMP, we don't have anything here. So let me install the SM platform, okay, called StreamNative Platform. Okay, this is it. I define this YAML file, right? So basically, this is the stream to deploy. Oh, forgot the name. That's one. Okay, so let's see what happened. Ooh, you see, ZooKeeper up, tool set up. Similar, right? But I only have one YAML file to control everything, right? So I don't need 3 CR YAML files. I just need one here. So the same, they try to pull the image. It's still pending, right? So, but the part you will see that I have many different. If you go to a lot, see the old namespace. There's a lot of part. This is called multi-tenancy. This is all controlled by the operator, right? So operator listen to my SM platform hand chart to deploy those components. You can also just do operator, create your own, right? So you can do this. You want to have multi-tenancy environment, right? So Kubeclt create an SMP2, right? Then if you install it in SMP2, you will have another cluster. You can have multiple cluster here, right? So this is called multi-tenancy by namespace. So one operator can deploy multiple Pulsar cluster using SM platform, right? And each values can be different. You can do upgrade. I want to change it okay, since we have initialized it, right? So you after you do upgrade, you don't need initialize. You can do, let's say, one basic S5, right? So basically you can, this will directly upgrade the platform, your SNP platform too. So this is how we using SM platform in private cloud by using a helm, right? So yeah, this is the lab. Let's go back to the slide. You see that this is some command. How do you, if we want to learn more detail about what it generates, you can use this template, so you can get more understanding about the platform here. Let's do that. Okay. So what happened here? This is kind of like a deep dive, right? What happened in the background? So you see that I'm trying to do not upgrade, not install, but template. So basically it's like, okay, tell me what the detailed plan your helm chart will do. So basically it write the sample file here. You see that there's a lot of things generated. For example, Pulsar operator, tool set, service account, those are all config map. Let's go through the doc here. Let me go through this doc. You see that that's a test tool, right? So go down. So test tool, this directory, you see, SM platform generate all the templates, manifest, CR, function worker. You see that all this auto config manifest, all those role binding. You remember I'll talk about the Kubernetes components, role binding, service, stateful set, right? It auto generate everything for you. You just need to fill in the values.yaml file, right? It will try to translate everything, external DNS, detector, custom resource. This folder keep growing. Datadog, Splunk, right? And other different resource. It's all here, right? BookKeeper. So you see that this basically, this is the CR. In lab 1, 2, 3, we do this, right? It auto-generates this for you. Broker the same, right? It's not just cluster, not the operator CR. That's other thing SM platform generate for you, right? So this is the point I say that SM platform is a composer, right? You define what you want in a values.yaml, then it generates those and automatically push them to here. You see that config map in SMP2, this is auto-generated. Secret auto-generated. Even we have resource quota, right? So job, network service is auto-generated. You see that that's all the service network component all set up for you. All the storage is here, right? So all the disk is auto-created for you. Okay, so yeah, this is our SM platform. Remember, our cloud offering is also built on this operator, right? But it's kind of a bit different. Let's see the API here. What's the difference? You will see the API version here, right? So this is a signature of the API. It's called zookeeper.streamnative.io, right? So in your SM cloud, you will see cloud.streamnative.io. It's kind of different, but it's different code here, right? So in short, the operator, this is the data plane. Okay, so in our SM cloud, we have control plane, right? So control plane tell data plane what to do, which means that it generates a CR, it generates different CR, and this is the data plane. It actually is the worker to deploy all the different components for you.